All right. Sorry for that. I wasn't able to monitor the time, so it just, it forcefully closed our meeting. Mm. May I know what are the other platforms that your other instructors are using? Is it Zoom meeting also? Or are they using a big blue button maybe? Or Google Meet?
They're
Zoom
using
meeting
Zoom.
lots, sir.
Zoom meeting then. And all of them has a limited time also, like limited to 40 minutes only.
Some of them do, some of them don't.
Some of them has a unlimited time, like you have a
Yes, sir.
premium version. Wow, good for them. Well, I don't have the money to pay for a premium version. So I saw someone raising his hand. So is that so? Anyone who has a question so far or a clarification? Okay, so I guess none. Anyway, so how many slides more? 28. So di na kasha. Anyway, let's try to finish whatever we can finish today, and then we'll just continue that as on Thursday. Okay. Okay. So before we start, or before we continue, rather, I would like you guys to give me a thumbs up just to let me know that everything is okay, or just to let me know that you guys are already in front of your computer. Okay, very good, Mr. Balboa. So I like your thumbs up. Mr. Rexor, you're raising your hand. So any questions so far? Di ba ka nagkamali lang? Okay then. So here are the answers. Okay, wherein we have already answered that one. So most of you were able to get the correct answer. So I'll just give you guys maybe 10 seconds to 15 seconds to recheck everything. Okay, so again, in order for you to know the total of elements or total combinations, just count the elements on that set versus on the second set. So 3 times 2 is 6. And then b times b is 2 times 2 is equal to 4. Okay. So let's now proceed to the different types of set. So empty set or null set. So they are just the same. So a set which does not contain any element is called empty set or the null set or the void set. So there's actually 3 names for that. We have empty set, null set, and then void set. So those 3 are just the same. Denoted by this, I think this is P, PHI. So yeah, so I'm correct. So it's P. So in roster form, P is denoted by this empty set. Okay, curly bracket, which doesn't have an element at all. Okay, and an empty set is a finite set also, since we can count the count of elements inside of it, which is actually none. Okay, so it's under finite set. And then since the number of elements in an empty set is finite, for example, it's 0. So this is just the number of cardinalities, meaning it doesn't have any count of elements. So for example, the set of whole numbers less than 0. So of course, clearly there is no whole number less than 0, because in whole numbers, we only have 0 and above. Okay, we don't have negative numbers. So therefore, it is an empty set. So I think this one is quite easy to understand. Okay. So anyway, let's have another example. So we have this set n, which x is an element of n, wherein x is greater than 3, and then x is less than 4. So n here is actually natural numbers. Okay. So in natural numbers, we start with 1 and above. So 1, 2, 3, 4. And if you guys are going to take a look on this one, there is no number in between of 3 and 4, since it's only under natural, excuse me, natural numbers. Okay. So here A is an empty set because there is no natural number between 2 and 3. Okay. And then for the letter B, or let B is equal to X is a composite number less than 4. Okay, so if you don't know what is a composite number, so I have the definition of composite number here. So composite number is a positive integer that can be formed by multiplying two smaller positive integers. Equivalently, it is a positive integer that has at least one divisor other than 1 in itself. So as a result, this set B, or here B, is an empty set because there is no composite number less than 4. Okay, so 2 and 3, so we cannot form a number since we have to multiply a whole number. So we cannot multiply 1.5 times 2 since 1.5 is not an integer anymore. Okay, so that is a composite number. Okay, so just take note that this one is not equal to this one. So this one is empty set itself. Okay, but this one is a set that has one element, which is 0. Okay, and then the cardinality, or the cardinal number of an empty set, is of course 0. Okay, so 0 count of elements, but this one has a cardinality of 1. So when we say cardinality, it is a count of elements inside of that set. Okay, so we'll talk about more cardinal numbers later on. But yeah, that is it for the empty set or null set. So are we clear so far? Question or clarification before we proceed to the next one? Okay, so I would assume that there is none since no one is speaking. So let's now proceed to the singleton set. So this one is also super obvious. Singleton has only one element. Okay, that's why it's called single or singleton. So for example, X is neither prime nor composite. So again, if you don't know what is the meaning of prime number or composite, has been already mentioned here, but a prime number, or a prime, is a natural number greater than 1 that is not a product of two smaller natural numbers. So a natural number greater than 1 is not a prime is called a composite number. So for example, 5 is prime because the only ways of writing it as a product is 1 times 5 or 5 times 1 involves 5 itself. So it has to be, the number itself has to be there for us to be able to call that one as a prime number. But if the number itself doesn't exist, we call that one a composite number. Like 2 times 2 is equal to 4. Okay. So in here, where is it? What it is a singleton set containing one element. Okay. So this one is neither prime nor composite. Okay. So let's have another example. Let's say B, X is a whole number wherein X is less than 1. And let's go back to the whole numbers. So we only have 0, 1, 2, 3, and 4. Okay, so the only element that is less than 1 is 0. So that is why this one is called singleton set. And then for the third one, we have here X is an element of n and X squared is equal to 4. So in here, we now have two conditions. Okay, so the first condition is X is a natural number. So what are those natural numbers? So we have 1 and above. And then we have another condition wherein X squared is equal to 4. So we must meet two conditions for us to be able to say that it is an element of that certain set, or that set A. So in here, there is only one element that can suffice those two conditions. So that is actually 2. So 2 squared is equal to 4. So there are no other numbers anymore that can suffice this one. Unless this one is not a natural number. If this is an integer, so we can have -2, but that is not a singleton set anymore since we now have two element on that set. Okay. And then for the last one, so let B, wherein X is an even prime number. So here B is a singleton set because there is only one prime number which is even, okay, which is the 2 itself. Okay, so there are no other even prime numbers that exist except the 2 itself. So are we clear so far when it comes to singleton set? Hello? Are you guys still around?
Yes,
Or
sir.
nagutom na?
Sir.
Okay? Oh, ang paulan na. Last ng thunderstorm. Anyway, let's proceed now to the next one, which is called the finite set. So this one is super obvious. It's called finite because we can count the number of elements inside of that set. Okay, so it has a limitation. Make it short. Okay, so in here we have 2, 3, 5, 7, 17, and up to 97. So it has a limitation. Okay, so the counterpart of that one is of course infinite set. Oh, infinite. The name itself already is saying the correct answer. Wherein we cannot count or we cannot list all of the elements inside of that set since it's infinite. Okay. So all infinite sets cannot be expressed in roster form. Okay. And then let's now talk about cardinal number of sets. So again, when we say cardinal number of sets, so it is a number of distinct elements in a given set. Set A is called the cardinal number of A. So it is denoted by n, closing up in parentheses, A. So meaning you are like saying the count of elements of A is equal to, so depending on how many elements or how many distinct elements we have in that set. So take note, it's distinct elements. So repeated elements must be removed first before you can count the cardinality of that set. Okay, so for example, we have this one, X is an element of n, and then X is less than 5. So again, in natural numbers, we only have a 1 and above, so 1, 2, 3, 4. So in here, we have 1, 2, 3, and then 4. Okay, so if you guys are going to count the distinct elements inside of the set A, we only have 4. So are we clear so far? So it's like, cardinal number is equal to the count of elements of that set. So did you guys get the idea so far? Okay, so the same with letter B. So B is equal to set of letters in the word algebra. And if you guys are going to take a look on this one, so if you are going to count this one, so we have 2, 4, 6, 7. Yes, we have 7, but then again, we have a repeated elements, which is A. So we can just remove the other one. So as a result, we now only have A, L, G, E, B, and then R. So we now have a total of 6 elements instead of 7. Okay, so I hope we're clear with the cardinal number of the set. Okay, so let's now proceed to the next one, which is the equivalent sets. So this one is two sets A and B are said to be equivalent if their cardinal number is the same. Okay, so most of my students before are confused with this equivalent and then equal. So when we say equivalent, so the one that we are looking for is the cardinality or the cardinal number of that set. So they must be equal in terms of counts of elements. Okay, so that doesn't matter if they have different distinct elements inside of them. Okay, as long as they have the same count of elements, they are already an equivalent set. Okay, so for example, this one, we have a set A which contains an element of 1, 2, 3. So the cardinality of this one is 3. And we have PQR for the letter B. So we have a cardinality of 3 also. So we could say that A is equivalent to set B. Okay. So are we still good? Were you guys able to follow so far? Okay. And then the one that we are talking that they must have the same elements. So this is not the what we're talking about. So the equal set. So we call that one equal. Okay, we're in, let's say A is equal to PQRS and B is PSRQ. So therefore we can say that A is equal to set B, or set A is equal to set B. Okay, so again, in set arrangement doesn't matter. So those two are equal. And at the same time, you could say that they are equivalent also, since they have the same count of uh, elements, okay, or they have the same cardinality. Okay, so I hope we're clear with the equal sets. So let's now proceed to the next one, which is the universal sets. So universal set is the set of all elements under consideration. So we could just say that universal is like the universe itself. Okay, so we could say that, in universe, it is a set wherein it contains the planet, Earth, Mars, Jupiter, Pluto, and so on and so forth. Okay, so it has a boundary, of course. After that one, the wide, you know, uh, after the universe, of course, is the galaxy. Okay, but let's just stick with the universe or universal. Okay, so this one is denoted by capital U. So this one is all other sets are subsets of the universal set. So again, it has a limitation. That doesn't mean that it's unlimited, or it's not bounded. So in here, it's bounded by this element. So given U is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so those are the elements that it can contain. Okay, and then we have set A, which has an element of 1, 2, 5, 6, and then set B, which contains an element of 3 and 9. So below is a Venn diagram to represent these sets. So this is the U itself. Okay, and then we have subset A, which contains an element of 1, 2, 5, 6, and then set B, which contains an element 3 and 9. And then the other that doesn't exist is just, inside of that U also. Okay, it's just that it is not inside of a certain set. Okay, we have 4, 8, and then 7. So think of a universal set as a big picture. It includes everything under consideration, which is depending on, you know, uh, the elements that's being mentioned, or everything that is relevant to the problem you have. An example above, or on the left side, we have A is a subset of U, and then B is a subset of U also. So note that subsets A and B do not overlap, so these sets are disjoint. Okay. So, are we clear with the universal sets? So, any questions so far? So, I think we can finish. Yeah, I think we can finish it today. So, let's try to finish this entire module to today. Anyway, so let's now proceed to. Oops. Okay, so we have already answered this one. I don't know why is it here. Okay, so we will skip this subset and then this proper subset uh, topic, since we have already discussed this one a while ago. Okay, but it's just in case that you need more example or clarification. So these are the answers. Okay, so the same with this one. Okay, for the proper subset. Okay. Okay, so let's talk about now superset. So when we say superset, it is a set containing all of the elements of another set. So it's like the mother set, the one that I keep on saying a while ago. Okay, so if you are going to draw this one, so A is the superset of B. Okay, meaning this is now the like the mother set, or the one that uh, contains all of the element of set B. Okay, so we have this example: A is equal to habit, B is AIT, and so on and so forth. So these are the answers. A is the superset of B because all of the elements of B can be found on superset B. A is the superset of C because all of the elements of C can be found on superset E. A is a superset of B. Oops, naulit. Okay, so let's just ignore this one. And then A is a superset of B because all of the elements of B can be found on superset E. And then A is a superset of E is also true because all of the elements of E can be found on superset E. Okay, or you can also add D is the superset of E. Okay, since all of the elements of E can be found on superset D. Okay, so
Sir,
our yes.
ano yung difference nilang dalawa ng universal set?
Why do you compare that one to superset? Universal set is like a rectangle or just a big picture which contains a certain elements. Okay, and superset is a set that contains all of the elements of its subset or proper subset. So I don't think we can compare those two. So there is no comparison since both of them are two different, representation or topic. Well, we can compare subset and proper subset, but the same with superset, we can compare those three. But universal set is just a representation of a bigger picture of something. Okay, so where is that part that you are, getting confused? So could you please elaborate more?
Sir?
So parang what do you mean? Like what is your difference?
Hindi kasi sir, parang 'di ba, yung universal set,
Mhm.
lahat ng nung yung dito sa example dito, A and B, lahat ng elements na is nasa universal set.
Mhm.
Then dito naman sa superset, yung element ng A, lahat ng element ng B, C, D, at E ay nasa A.
Mm,
Parang ganun.
that's right. You can also say that this is the universal set already, but still, we can still call this one as superset. We can also call this one a superset. Okay, since C is the superset of D, since we can still find the elements of D on C. Okay, so unlike in universal set, there's only one. Okay, which is this elements, but for superset, so four of them can become a superset actually. Okay, but yeah, you're actually also correct that we could say that A is like a universal set. 7, 8, 4 are not subsets. No, they are not subsets. They are just element inside of that universal set. Okay, so again, when we say subset, so it must be inside of a set also. Okay, wherein 7 is just an element, 8 is just an element, the same with 4. Okay. Uh, was I able to answer your question? That makes it
Yes.
different to superset?
Yes po.
Mm, yes, pwede. So, in universal set, so yeah, that one is correct. 7, 8, and 4 is not a subset. Unlike in superset, so the letter B, C, B, D, and then E right here are the subsets already. Okay, so you can actually, just flip this one, and this one now is like a subset. Any other concerns before we proceed to the next one? Okay, so any other question, Mr. Sian? Was I able to answer your question?
Yes po.
Okay. What about you, Mr. Derek, Prince, Umanhan? Do you have any other concerns? So it seems that, okay, so it's here. Okay, so let's now proceed to the relation. Okay, so to make it simple, relation composes of two elements, okay, wherein we must have this first element and then this second element for us to call that one as a relation. So the same with, how we uh, call that we are related to to our parents, and we are related to our friends, or how we are related to our maybe colleagues. Okay, so those are called relations. So in here, relation R from A to B is a subset of A times B. Given an ordered pair x, y in A times B, x is related to y by R, written x related to y, if and only if x and y is in relation. So we can only say that x is related to y if it meets the condition. Okay, so later on, I will have an example with this one. So the set A is called the domain of R, and set B is called its codomain. So the first element is the domain, and then the second element is the codomain. Okay, so the notation for a relation R may be written symbolically as follows. So x or y, or x is in relation to y, means that xy is an element of R, or an element of relation. Okay, so the notation x is not related to y means that x is not related to y by R, or in symbolic form, x is not related to y means that xy is not an element of R. So they are in relation if they were able to meet the condition, but they are not in relation, okay, or they are not in or they are not an element of R if they wasn't able to meet the condition. Okay, so for you to be able to say that yes, they are in relation, this A and B is in relation with each other, so you must be able to meet the condition first. So that is the one that we are going to look for us to be able to say that they are in relation with each other. Anyway, let's have an example. So a relation as a subset. So we have set A as 1 and 2, and then set B as 1, 2, and 3, and define a relation R from A to B as follows. So given any x, y is an element of A times B. So in here, you must get all of the ordered pairs first, okay, because we can only say that they are in relation if they were able to meet this condition. So with that, you have to list all of the ordered pair first, and then substitute the values of x and y in this condition. So x and y is an element of R, means that x minus y divided by 2 is an integer. So if it's an integer, then they are in relation. But if it's not an integer, then they are not in relation. So with that, let me just check if we have the result. Yeah, okay. So to make it quick, okay, so all you need to do is list all of the ordered pair first. So we have 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3. Okay. And here are now the list of ordered pairs. Then after that, you have to substitute the values of those ordered pairs on our condition, wherein x minus y divided by 2 is an integer. So here are all of the results. So we have 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, and then just substitute the values right here. Okay, so 1 minus 1 divided by 2 is equal to 0 divided by 2, which is equal to 0, which is an integer actually. Okay, and then 1, 2 is actually equal to negative 1 divided by 2, or negative 1 half, wherein negative 0.5 or negative 1 half is not an integer. And so on and so forth. So all you need to do is substitute those list of ordered pairs, and then just get all of the relations that is, we're able to meet the condition. So we have 3 that was able to meet the condition. So we have ordered pair 1, 1, ordered pair 1, 3, and then ordered pair 2, 2. And then just ignore the rest. Okay. So where is okay? So this is already the answer for the letter A. So what is the question in letter A? So state explicitly which ordered pairs are in A times B, which are in R, or which are in relation. Okay, so we only have 3 relations. So 1, 1, 1, 3, and then 2, 2. So were you guys able to follow the letter A? Is it clear so far? So 9 slides left. Thanks. And 8 minutes remaining. Okay, so this is the answer for letter A, and then this is the answer for letter B. So is 1 related to 3? So just base it right here. So 1, 3 is yes. So that's why we have an answer of true. And then 2, 3. So 2, 3 is not an integer. So that's why we have an answer of false. And then 2, 2, okay, is yes. So that is why we have an answer of true right here. Okay, so are we clear with letter B? And then for the last one, so this one is super simple. What are the domain and codomain of relation? So all you need to do is get the ordered pair which is in relation. So we have 1, 1, 1, 3, and then 2, 2. So we have for the domain, okay, so we have 1 to right here because we have 1, and then we have 2. Okay, so we have 2 repeated 1, so just remove that 1 since we only need 1. So that is why we have 1 and then 1, 2. So that is already our domain, or the first element for the relation or pair. And then for the codomain, so that is the second element. So we have 1, we have 3, and then we have 2. So as a result, we have 1, 2, and then 3. Okay. So for this one, you guys have to check the ordered pair which was able to form a relation. Okay. So are we clear with the letter C, the domains and codomains?
Yes, sir.
Okay, very good. So answer as quick as possible since we are now running of time. So let's have another example. So the circle relation. So define a relation C from R to R as follows. For any x, y is an element of R times R. So this R right here is a real number. So any number that you can think of. Okay. So x, y is an element of C means that x squared plus y squared is equal to 1. So all you need to do is get all of the possible combinations. But it would be infinite, of course, since uh, especially we're talking about real numbers, so it's like everything already. So we have a uh, given ordered pair in here, okay, wherein is 1, 0 is an element of C. So is this ordered pair in relation with each other? So before it was represented by R, but in here it's now represented by C, meaning it's a circle relation. So again, for us to be able to say that they are in relation, if you were able to meet this condition, x squared plus y squared is equal to 1. So this is the x and then this is the y. So 1 squared is 1, and then 0 squared is 0. So 1 is equal to 1. So A is yes. How about letter B? B is no, that's correct. Very good, Mr. Jeo. Letter C? So for this time, I would like you guys to use your calculator. Unless you're a math genius and you can compute this square root of 3 divided by 2. Okay, so the correct answer is yes. Okay, so to the others, please verify this one. And then for letter D, so this one is super obvious. Letter D, is it yes or no? So this one could be represented by, this one. Is this ordered pair an element of circle relation? Or we could just say is -2 in relation, in relationship with element O. I mean 0, not O. So letter D is no, okay? How about letter E? E. What is the answer in E? So yes, correct answer is yes. Okay, what about letter F? Hmm? Yes? Okay, the correct answer in letter F is no. Okay, 1 squared plus 1 squared is already equal to 2, wherein 2 is not equal to 1. So 1 is not in relation with 1. Okay, and then what are the domain and codomain of C? Okay, so let me answer letter G. So in here, the domain and codomain are this. Okay, so anything is actually possible, and then we cannot list everything. So in other words, we can just say that the domain and codomain of circle relation is R, okay, or real numbers. Okay, so we've just used those numbers to answer this uh, relation right here with this condition. But to make it exact, all of the domains is R, and then all of the codomains is R also, or RR. Okay, since marami sila. Okay, so here are the answers. So we now only have 1 minute and 45 seconds left, and we still have 7 slides remaining. Anyway, so I think we cannot finish this one today, unless you guys are willing to, have another meeting. Is it okay? Will it be okay, guys? We're going to have a part 4, maybe just maybe 5 to 10 minutes, just to finish everything. So that you guys can answer everything now. Okay, those 8 quizzes. Okay, since we still have two topics left: the arrow diagrams and then the function. Okay, anyway, so uh let's have another votation. So 1 minute left. So are you guys willing to have a part 4?
Yes po.
Okay, what about the others?
Okay
10
lang
minutes lang
po.
na.
Yes,
Okay
sir.
lang.
Okay, so I will end our meeting now, and then let's just meet on part 4. Okay, so 7 slides left. Okay, so goodbye, and let's just meet again on part 4.